Have a go at the questions on this page. Pause the video and then I'll go through them in a second. Right, so the main thing we first need to recall is that x squared plus y squared equals r squared for the equation of a circle. And in this case, the radius is 2. That's what this little 2 represents. It's 2 there, but it's 2 all the way around. And so the equation of this circle is just going to be x squared plus y squared equals 2 squared, or just 4. Second question, the diameter of a circle centered at the origin, that's really important. This equation only applies when the circle is centered at the origin, is 10. Write down the equation of the circle. So if the diameter is 10, the radius is half, that is going to be 5. And we again get the answer really quickly. X squared plus y squared equals r squared. So in this case, 25. Calculate the exact area of the circle with equation x squared plus y squared equals 12. Well, that means that r squared is equal to 12. And we could square root it to get r. But actually, the area is pi r squared of a circle. And so it's just going to be pi times 12, or 12 pi. We actually get the area really quickly. Moving on to some slightly trickier ones. So x squared plus y squared is 169. x12 lies in the circle where x greater than 0. Work out the value for x. So I can substitute in my value of y to figure this out. It's going to be x squared plus 12 squared is 169. That's 144. So I'm going to do x squared is 169 minus 144, which is 25, I believe. And that means x is going to be plus or minus 5. I've taken the square root, but I've included the positive and the negative. Because you get two solutions for y value. For a given y value, you're going to get, for a given y value, you're going to get two different x values on this circle here. But it does say that x is greater than 0. So in fact, x is going to equal 5. Similar for this next one, but this time we're given the value for x. I'm going to substitute that in. If x is root 5, then x squared is going to equal 5. It's just I'm just squaring the square root to get back to the original number. So 5 plus y squared is equal to 30. I'm going to get that y squared is 25. I've actually got the same number. I didn't really mean that, but that's okay. So y is going to be now plus or minus 5. But I'm told here that y is less than 0. So I'm going to reject the positive. There are two solutions. Then I'm interested in the one that is valid. Okay, last little bit, we've got in a circle, so we can see that the radius is going to be the square root of 400, which is 20. Just going to write that down. Show that a certain point lies on the circle. The left-hand side is going to be 16 squared plus minus 12 squared. 16 squared, I think, is 256. Plus 144, and that is equal to 400. And so, because I've got it, I'm running out of space here. Because I've got that, it's gonna, I could say maybe equals right-hand side. So, I should just write a conclusion, because it's a show that question. So, 16 minus 12 lies on the circle. If it didn't equal 400, then we know it doesn't lie on the circle, but what we wouldn't have shown is whether it lies outside or inside. So for part B, I've got a slightly different approach, and I could have used this for part A, to be fair. I can work out the distance from the origin to the points, because it's just going to be 15, 15. I'm going to go along 15 and up 15. So I'm kind of hijacking this this diagram, but along 15 and up 15, so I can use Pythagoras' theorem to work out the distance from the origin to the points. And if that's less than the radius, then it's inside the circle. If it's more than the radius, it's outside the circle. If it's equal to the radius, then it's on the circle. To be honest, that might be the approach to go with in general, because it looks like I'm doing two different approaches here. But there are times when this is really helpful, this part A one. So distance from 0, 0 to 15, 15. equals 15 squared plus 15 squared, square rooted. 15 squared, I believe, is 225. So it's going to be 225 plus 225 square rooted, which is root 450. And this is going to be greater than 20, which is the radius. So basically shown that the point is actually going to go beyond the circle. The radius is 20, but this is going to be more than that. I don't actually need to figure it out. I could if I wanted to, but I'm doing this without a calculator. So yeah, this is definitely greater than 20 because root 400 is equal to 20. So root 450 must be bigger. So 15 lies outside the circle. Okay, good start. We've looked at the equation of a circle. Today, we're going to be calculating the equation of a tangent to a circle. So we've got our circle. The tangent is a line that just touches, that was a pretty good tangent, I've got to say, just glances off of the circle. So it could be here, it could be another one, like it could be down. That was not such a great one, but it just kind of glances off. And this involves a lot of topics kind of combined together. So what I'm going to do is I'm going to take it step by step, just remind you about topics, but I want you to kind of pause the video in places and try and figure out these things yourselves. And then we're going to bring it all together, and it'll just be like, here's a circle with such and such information. Find the equation of the tangent. That's the outcome. All right. So to start with, I've got some equations of some lines. I want you to write down the gradient. And then I want you to write down the perpendicular gradient. This is going to come in useful. You'll see why in a bit. So hopefully you've had a go at this. The gradient is going to be 3 for this one. And that means the perpendicular gradient is going to be minus a third. I'm not going to go into loads of detail on this. There's lessons on perpendicular gradient if you want to look back at that. It's the negative reciprocal, or equivalently multiplied together to give you minus 1. Here it's 2/3 because it's always a number in front of the x. Remember, it's y equals mx plus c. I'm assuming knowledge of that. So the perpendicular gradient is the negative reciprocal. You basically flip it round, it becomes minus 3/2. Here the gradient is minus 5. It's the number in front of the x. Remember, it doesn't matter that the 7 is first in this case. And then the negative reciprocal is going to become positive 1/5. And over here, we get another negative, it's minus a quarter. So it's going to become positive 4/1, which is just 4, and we tend to just write it as the whole number. So hopefully you're happy with that. You're in a good place with your reading y equals mx plus c and identifying then perpendicular gradients. Next question for you to try then. Can you find the equation of the radius passing through 4, 3? Right, I'm going to talk through this one. So passing through 4, 3, I didn't actually say in this question, but this does lie on the circle. So this is 4, 3. And then what do we need to do to find the equation of the radius? It's going to be y equals mx plus c. It's going to be a straight line. It's the equation of this blue line here, essentially. I know it goes through 4, 3, but I also know it goes through 0, 0. I can work out the gradients by doing rise over run. So I go along 4, and I go up 3. I could equivalently do y2 minus y1 over x2 minus x1. In both cases, I'm going to get 3/4. So I'm going to get y is equal to 3/4 x plus c. In this special case, I can see that it goes through the origin, so c is going to equal 0. If I don't spot that, I can substitute in for either value, and I will, again, get the same thing. So we can work out the equation of the radius. That's not the same as working out the equation of the tangent, but it's like a little stepping stone, so I wanted to cover that first. Okay, second question. So if I have the radius, because like what I'm trying to do here is build up between the relationship between the radius, or the line that goes from the center to the edge. I'm calling it the equation of the radius. It's actually called the equation of the normal, but I didn't want to throw that new word in, so I'm going with the radius. Right, what's the angle between this line, this normal or this radius line, and the tangent? What do you think it is? What is it? I suppose what I'm asking is, what does it look like? And the answer is that it is in fact 90 degrees. It is always 90 degrees. Wherever you draw, so if I draw one up here with a different tangent, this will be 90 degrees. This is in fact a circle theorem, but I'm kind of teaching this topic assuming that you've not covered circle theorems. If you have, you might be like, oh yeah, I already knew that, or yeah, I remember. But I'm covering it from scratch. So something to be aware of is that the tangent and the line that meets it from the radius, this normal, is always 90 degrees. That is a mathematical fact. I'm not going to prove it. I'm just going to kind of ask you to, yeah, it looks like it is in this case, but trust me, it always is. So we're able to find the gradient of the radius or the normal. We've got the relationship now between the tangent and that line, and you might be able to see what's coming. These are perpendicular lines. So can you find the gradient of the tangent touching the curve at -2, 1? If you're confident, give it a go, otherwise I'll go through it. So the gradient of the tangent is going to be the negative reciprocal of the gradient of the radius. This is going to be 0, 0. This now is going to be -2 and 1. So I can see that I'm actually kind of going back 2 and up 1. I'm going to kind of do it, yeah, using that. You might say you're going down 1 along 2. It's equivalent. So for the radius line, we've got the m is going to be rise over run, so it's going to be 1 over -2. It's going to be -1/2. You might find it easier in this case to do y2 minus y1 over x2 minus x1. Okay, it should get -1/2. Right, so tangent gradient, because of this up here, is going to be the negative reciprocal, and it's going to equal, that's meant to be an equals, it's going to equal 2. And you can actually see it from, this graph is drawn to scale. I'm going along 1. Actually, is it drawn to scale? Yes, it is. I'm going along 1 and up 2. That is the gradient, but I don't want you to read it off the graph. That was just me checking it. We need to be able to do it without the diagram in theory, or without at least it being to scale. So let's just recap. We can find the gradient of the radius line. We know how it now links between, like, to the tangent. They are perpendicular lines. And so I can use the negative reciprocal to write down the gradient of the tangent. And we've done the main bit because we're trying to find the equation of the tangent. So now we've got the gradient of the tangent and we've got a point that it goes through. So let's put it all together. Well, actually, I tell a lie. I'm going to test you on a few things first. Okay, just to check your understanding. Here it goes. Pause the video, try each question. I'll go through them. What is the gradient of the radius of the circle to the point 3, 4? Well, I'm going along 3, I'm going up 4. It's going to be 4 over 3. What's the gradient of the radius to this point? In this case, I'm going back -1 and up 3. So it's going to be 3 over -1, which is -3. You might have done it by considering this is -3 and this is +1. Like if you're moving along in the right direction, that's okay as well. If you're sort of thinking about the movement from this point, you get the same thing. Right, what's the gradient of the tangent to the circle at the point -2, -3? The tangent. Okay, we first of all need the gradient of this radius line, and I'm going back -2 and down -3. So the gradient is going to be -3 over -2, which is just 3 over 2. but it's asked me for the gradient of the tangent, which remember is the line that just glances off of it. That's not a great tangent, but it's good enough. That is going to be the negative reciprocal, which is I'm going to flip it around, make it negative. It's going to be minus 2/3. So well done if you got that, because that's a crucial bit of the lesson. Okay, then finally, which of these is the gradient of the line through O and M? I've got a tangent. What's the gradient of the line through O and M? Okay, the gradient of the tangent is actually given in this case. This is like a reverse kind of problem. If I gave you the gradient of the tangent, could you work back to the gradient of this radius? So I've got minus 3 here. Remember, they are perpendicular, so it's a negative reciprocal. It's going to be 1/3. Okay, I hope that's in good shape. Let's keep going. So we're now nearly there. Here's the full thing. Let's do this. I'll go through this one, and then I want you to try the second one, because there's lots of steps. But if you've got your mathematical understanding in place, you've learned about these topics, y equals mx plus c, reciprocals, this circle theorem, then it's just a matter of putting it all together. It's a case of practicing and mastering it. Here goes then. Right, we've got 0, 0 is the center, and we've got 1, 2 as this point here. So the first thing I'm going to do is get the radius line, or the normal line. I'm going to actually write that word down, because that is technically the correct word. The line that is perpendicular to the tangent, that's kind of the definition. So it's strange to call it the normal before you've introduced the tangent. But anyway, right, we know this is 90 degrees. I need to work out, and I've not left much space, but I need to work out the gradient of the radius, or this normal. I'm going along 1 and up 2, so m is just going to equal 2. That means the tangent, m, is going to equal minus 1/2, the negative reciprocal. And by the way, if I didn't have this diagram, I could still do this question, because I would just do y2 minus y1 over x. Don't expect to always have a diagram. x2 minus x1, so I'll pick this as y2. It's going to be 2 minus 0. I'll pick, then this is going to be x1, so then it's, x2. So it's going to be 1 minus 0. I still get the same thing, 2, for the normal. Right, we've got a tangent, so then we can write down, if you've understood finding the equation of a line given 2 points, or the equation of a line perpendicular to another line given a point, and equation of a parallel line given a point, and this is just an extension of that. We've now got the gradient of the line, and we've got a point going through it. So it's going to be y is equal to minus 1/2 x plus c. But now I cannot use this 0, 0. It doesn't go through there. It does go through 1, 2. So when x equals 1, y is equal to 2, substitute that in. 2 equals minus 1/2 times 1, which is just minus 1/2, plus c. And c is going to equal 2.5, or 2.5. So finally, y equals minus 1/2 x plus 2.5. I'm going to write, I don't know, it feels weird to leave a fraction here and then a decimal there, so I'll leave it as 2.5, or 5 over 2, and there we go. That is our first full example of the equation of a tangent. I didn't want to go straight into that. I've tried to build up slowly, because there's a lot going on here. I kind of glossed over the facts about the negative reciprocal here. So since they are perpendicular, that's in there. Okay, hopefully you like this, but this is deemed a difficult topic at GCSEs. Just keep practicing. Try this one yourselves. Okay, let's do I'm going to call it the normal now. Just going to call it the proper thing. So m is going to be 2 minus 0 over 2 minus 0. I'm going to imagine I didn't have this sketch. So it's going to be 1. That's going to be the gradient of my normal, or my radius. Tangent is perpendicular. By the way, this is the notation for perpendicular. So m is going to be the negative reciprocal. It's actually going to be minus 1. It's minus 1 over 1. That's just minus 1. I've then got the point that it goes through when x equals 2, y equals 2. Do you know what? I forgot one little bit, didn't I? Before I do that, I should write down that y is equal to minus x plus c. mx plus c, but m is minus 1. Okay, that's really important. So then I get 2 is equal to minus 2 plus c. I've just substituted in for 2 and 2. So c is equal to 4. And I'm done. Y equals minus x plus 4. In this case, I can look at the sketch and think, yep, that's 4. It is to scale, but I can do it without the sketch as well. If you got that, brilliant. If not, I hope it makes sense now. Okay, the rest of this is you doing some practice. So here are a load of questions. Try and work your way through it, look for your notes, and master this topic. It's one that needs revisiting. Maths is like this cumulative thing. Okay, you've got to revisit it, but it'll help you. If you can master this, then you will have mastered all the other topics before it.